Hello everyone. I'm going to be working out a few problems from sections 3.5 and 3.6. I may move a little bit fast in this video. If I do, you can always pause the video in order to catch up, or you might be able to even play the video back slower. In this type of problem, we're not going to particularly care about sketching the function itself. We can always graph the function in something like Desmos. If you're not aware, Desmos.com, that's DESMOS.com. This is a really good online graphing calculator, completely free. I know that once I find the velocity function and the acceleration function, I would be able to find their graphs really easily. So we're going to first look at find the velocity function. I'm given that the position function here, s of t, is -5 times cosine of t. I know that the derivative of the cosine function is negative sine. So I know that the velocity function here is going to be s prime of t. This is going to be whatever I get. The derivative with respect to time of -5 times cosine of t. This is going to be -5 times negative sine of t, or positive 5 sine of t. For determining the times when the velocity is 0 over one period of the sine function lasts 2 pi. So we're looking for part D. We're looking for when time is between 0 and 2 pi. So I want to find where is 5 sine of t equal to 0 between 0 and 2 pi. Sorry, I see that some of this is getting cut off at the bottom. My screen isn't entirely matching up with the window capture. Let me see now if I write down here. That's a little bit better. I can divide both sides by 5, and I get that sine of t is equal to 0 if I do so, because 0 divided by 5 is still 0. And the places where the sine function is equal to 0 on this interval are going to be at 0 and pi. Sorry, I had mistakenly written that this is less than or equal to here. We do want this to be just less than on this right hand side. So the times when the velocity is 0 over one period should just be at t equals 0 and t equals pi. And the last part of this question was to find the acceleration function. Here I had that s of t was -5 cosine of t. I then had that v of t was 5 sine of t. I know that a of t, the acceleration function, is, well, it's v prime of t, or you can also think of this as s double prime of t. This will be the derivative with respect to time of the velocity function. And this will be 5 cosine of t. This is question 210 from section 3.5. Here we're asked what the second derivative of the given function is. So we need to start this out by finding what the first derivative of this is, what y prime is. We can take the derivative of this first part all by itself. That's just 3 cosine of x, plus, with this next part, we need to apply the product rule. It might be helpful for us to break this down like f of x is x squared, so f prime of x is 2x. This means that g of x is cosine of x, so g prime of x will be negative sine of x. I need to zoom out a little bit here so that all of this can be on the screen. I'm also going to change this color to distinguish this from the rest of my work. Oh. And then maybe we can move this over. I think I'm going to need a little bit more room. So now I'm going to put some brackets here so we can use our product rule. Our product rule is derivative of the first, that's f prime, times g, it's cosine x, plus the derivative of the second times the first. So that's g prime times f. That's negative sine x times x squared. So y prime is 3 cosine of x plus 2x cosine of x minus x squared sine of x. We can see here that my second derivative is going to have 2 product rules in it. I'm going to need a product rule for this part and for this part. Y double prime, the second derivative of y. Well, I can find the derivative of this first part nice and easy. The derivative of 3 cosine of x is 3 times negative sine of x. We'll multiply this out at the end, or in the next step. Plus, derivative of the first here is the derivative of 2x. The derivative of 2x is 2 times cosine x plus the derivative of cosine x is negative sine x times 2x and then I'm going to write on the next line our next product rule. This is actually a minus, right? The derivative of x squared is 2x. I multiply this times the second function, plus the derivative of sine of x is cosine of x, and I multiply this times x squared. And from here, we can do all of this multiplication and potentially simplify a little bit. So y double prime is negative 3 sine of x plus 2 cosine x minus 2x sine x minus 2x sine x plus x squared cosine x. Sorry, minus, right? Distributing the minus sign here. So y double prime is negative 3 sine x. I'm going to rearrange this. Whenever I combine these two things, I have minus 4x sine x plus 2 cosine x minus x squared cosine x. And we could actually factor these nicely if we wanted to. We could factor a sine of x out of everything here, and we could factor a cosine x out of everything here to give me sine x times, or you know what, we can make this here, make it negative 3 minus 4x times sine x plus 2 minus x squared cosine x. It's perfectly fine to leave our answer like this for the most part, but sometimes it's nice to factor it like this. Now we're going to look at a few problems from section 3.6. The first I had a question about was question 241. Find the equation of the tangent line to y equals negative sine of x over 2 at the origin. Use a calculator to graph the function and the tangent line together. So remember that the origin is the point 0, 0. This is nice. Whenever I want to find an equation of a tangent line, I always need a point and a slope. I already have a point. Now I just need to find the slope of the tangent line. In order to find the slope of the tangent line, I need to find the derivative of this function and plug 0 in. So I need to find y prime. Y prime is negative cosine of x over 2 times the derivative of the inside, right? This is the derivative with respect to x of x over 2. So y prime is negative cosine of x over 2 times the derivative of x over 2 is 1/2. So y prime is negative cosine of x over 2 over 2. Now I need to find the slope of this tangent line by plugging this x value of 0 into this derivative. So the slope of my tangent line, m, is going to be negative cosine of 0 over 2 all over 2. Obviously it's not over 0. Cosine of 0 is 1. So this is negative 1 over 2. And remember that this is passing through the point 0, 0. I can now use point slope form, I think is the easiest way to place this into a linear form. Point slope form is y minus y1 equals m times x minus x1. And in this case, this is y minus 0 equals negative 1/2 times x minus 0. So y equals negative 1/2 x. And this is the equation of my tangent line. And our next problem is question 256. Oh, I made that too large. The formula for the area of a circle is A equals pi r squared, where r is the radius of the circle. Suppose the circle is expanding, meaning that both the area A and the radius r are expanding. Suppose that r is equal to 2 minus 100 over t plus 7 squared, where t is time in seconds. Use the chain rule to find the rate at which the area is expanding. And then use A to find the rate at which the area is expanding at t equals 4 seconds. So note here that it gives us the derivative of the area with respect to time. This is the derivative of the area with respect to the change of the radius times the derivative of the radius with respect to time. So the first thing I want to do is find dA dt. Let's find some expression for dA dt. The derivative of the area with respect to time is going to be 2 pi r times dr dt. This dr dt comes from the chain rule because here r is a function of time. And I don't yet know what this dr dt is. And I don't know what r is. Well, I do know what r is. I have a formula for it, right? So now I can use the function that I have for r to also determine what dr dt is. So dr dt is going to be the derivative of r here. It's going to be the derivative with respect to time of 2 minus, I'm going to rewrite this as 100 times t plus 7 to the negative 2. We should get in this good habit of rewriting these as negative exponents whenever we see something raised to a power in the denominator. Let's see. The derivative of 2 is 0. Whenever I apply the power rule to this second part, I get negative 2 times negative 100 to the t plus 7 to the negative 3. This is 200 times t plus 7 to the negative 3, or 200 over t plus 7 cubed. And this is my dr dt. We said that dA dt was 2 pi r times dr dt. This is my dr dt. And remember that r we were given as 2 minus 100 over t plus 7 squared. And now we can plug all of this stuff in. So dA dt is equal to 2 times pi times 2 minus 100 over t plus 7 squared times 200 over t plus 7 cubed. I think that I should change this to be like this. At this point, I think it's fine if we don't fully distribute this and simplify. There's only one other part, which was just use this equation that we have to find the rate at which the area is expanding at t equals 4. So all we have to do is plug 4 in. So this would be 2 pi times 2 minus 100 over 4 plus 7 squared times 200 over t plus 7. Sorry, this is 4 plus 7 cubed. And when typing this into a calculator, since 4 plus 7 is 11, I just wrote 11 here. I think we get about 1.1079873. And this is the last one. The depth in feet of water at a dock changes with the rise and fall of tides. The depth is modeled by the function d of t equals 5 sine of pi over 6t minus 7 pi over 6 plus 8, where t is the number of hours after midnight. Find the rate at which the depth is changing at 6 a.m. So since we're being asked to find the rate at which the depth is changing, we know that we're being asked to find a derivative. So we want to find d prime of t. This is going to be 5 cosine of pi over 6t minus 7 pi over 6. Remember that whenever we're applying the chain rule, that we don't change anything inside the function, times the derivative of the inside, right? In other words, times the derivative of pi over 6t minus 7 pi over 6. Just rewriting the first part of the function. Remember that pi is just a number. So the derivative of pi over 6 times t minus 7 pi over 6 is just going to be this pi over 6 part, because it's the only part that had a t involved. And this is 5 pi over 6 times cosine of pi over 6 t minus 7 pi over 6. This is d prime of t. And we're being asked to find the rate at which the depth is changing at 6 a.m. Here, t is the number of hours after midnight. 6 a.m. is 6 hours after midnight, so I'm being asked to find d prime of 6. This is 5 pi over 6 times cosine of pi over 6 times 6 minus 7 pi over 6. This is 5 pi over 6 times cosine of pi minus 7 pi over 6, which is 5 pi over 6 times cosine of negative pi over 6. Now, cosine has this really nice property where cosine is an even function. Because cosine is an even function, cosine of negative pi over 6 is actually the same thing as cosine of positive pi over 6. And cosine of pi over 6 is going to be square root of 3 over 2. So it's going to be 5 pi over 6 times the square root of 3 over 2. This is going to be 5 root 3 times pi. Here, we'll write this as 5 pi root 3 over 12. And then we'll plug this into a calculator. And plugging this into a calculator, we should get about 2.267 feet per hour.